Distance time graphs. Here we have a distance time graph with distance on the y-axis in meters, time on the x-axis in seconds. Looking at the journey from A to B, we have a straight line with a small gradient. This gives a constant speed. We can calculate the speed from the gradient of the line. The gradient is the change in the y value, which in this case is 10 meters, divided by the change in the x value of 2 seconds. So the speed is 10 meters over 2 seconds, 5 meters per second. From B to C we have a horizontal line. The car's staying at 10 meters, so it's stationary. From C to D we have a straight line with a steeper gradient than from A to B. This again is a constant speed. The gradient will give the speed. The change in y value is from 10 to 30 meters, which is 20 meters. Change in x value is again 2 seconds. So here the speed is 20 meters over 2 seconds, 10 meters per second. The gradient gives the speed, so from D to E the gradient is reducing and the car is decelerating. So the gradient of a distance time graph gives the speed. The car moves at a low speed, stops, moves at a higher speed, and then slows down. Here we have another distance time graph. In this case the graph is curving. We have a low gradient, so the car starts off slowly, gets faster, and then gets slower again and stops. If we want to work out the speed at a particular point, what we can do is draw a tangent that has the same gradient as the curve at that point. So at 4 seconds, for instance, we can draw a tangent and the straight line has the same gradient as the curve at this point. Draw the line as long as possible. We can then find the gradient of that tangent. That gives the gradient of the curve at 4 seconds, and so gives the speed at 4 seconds. Here we have a change in the y value of 36 meters, the x value of 4 seconds. So the speed is 36 meters over 4 seconds, which is 9 meters per second.